Hello there, welcome to video number 180. This video is on trigonometry and the sine rule. Keywords are trigonometry, sine and inverses for higher students only. Obviously very welcome to watch if you want to, if you're not doing higher maths, but it might not be of use to you. Now there are two versions of this rule that you can use and substitute into to find missing sides or missing angles in triangles that are non-right angled triangles. This is when you have non-right angled triangles. Trigonometry, I mentioned in the trigonometry video, is the branch of mathematics that allows you to find missing side lengths and angles using sine, cos or tan. Sine is the one that we're using in the sine rule, funnily enough, and inverse means to undo, and that's what you do when you find angles. You inverse the trig ratio to get the angle in the end. So the method states, use this rule when you have an untidy looking question. All right, and what I mean by that, and it's not really a mathematical thing at all, it's just an untidy looking question. It means that you could have two angles and a side, or any two angles and a side. All right, and you could have any two sides and an angle that's not included within the two sides, and you could use the sine rule. Okay, so I think of them as untidy looking questions because they don't look neat to me. All right, that's the way I refer to it. Now, to find a missing angle or side in a non-right angled triangle, you label the sides A, B and C, the angles A, B and C, and you label the sides little a, little b, little c. Okay, write out the formula, and you have to decide what version of the formula you want to use. And in this black box up here, I've got the sine rule for sides and the sine rule for angles, and it's almost identical. You see the little letters are on top when you want to find the sides, and the little letters are on bottom when you want to find the angles. So you write out the formula and you choose the two parts of the formula that you need. There's always going to be one that you're going to be able to cross off and say, I'm not going to use that part of it. It's going to be the A bit, the B bit, or the C bit. Right? You substitute into it, you calculate, and then you inverse the sign if you're finding an angle. All right, and that's it. Okay, so find the value of x. Give your answer to one decimal place. This is basically just substitution and memorizing the rules. Okay, identifying what rule to use is important. It's a really important part of understanding this topic well. So in this question, for me, this looks like an untidy looking question because we've got two angles and a side, right? And we want to find this side length here. Okay, so we can do that, and we can use the sine rule to do that. And we have to remember the sine rule for finding sides is A over sine of A, which equals B over sine of B, which equals C over sine of C. And there you go, there's our rule. All right, now I'm going to label these sides A, B and C, and it doesn't really matter what ones you label what. All right, we could get this angle here as well if we wanted to. We could figure that out because we know what angles in a triangle add up to, and we've got two of those angles. All right, sometimes you have to do that, but we'll call this side here, we'll say that one's A, okay, because we've got the angle for A and we've got the side length for A, so therefore that's little a because it's opposite the big A. All right, let's call this side B, right? This angle B, and then this side will be little b. All right, so C will be irrelevant for us in this particular problem. There's angle C here, and there's a little c there for the side length. All right, nothing on there. Nothing there, don't need this part of the rule. Okay, so only using two parts of it. Now we're going to substitute into it. So A, or little a, is 22, so 22 goes on the top there. Sine of A, sine of 58, goes on the bottom. Sine, open bracket, 58, close bracket, equals, then we've got B, well B is our x value, so put x there, and then that's over sine of 73. Okay, and then this is just an equation. All right, we can solve it like any other equation. Remember, these are just numbers. All right, so we're going to multiply by sine 73 on both sides. What that looks like is 22 over sine of 58 multiplied by sine of 73 equals x. Okay, you could put that in some brackets if you wanted to, because that's one number there, right? It might need to on my calculator. Other calculators probably a bit better. So if I bring my calculator in, you'll see what I'm talking about. That's the bit that we need to type in now. So I'm going to put that in brackets at 22 over sine of 58. And then I'm going to multiply it by, after I've closed the bracket, sine of 73 equals, there's our answer, right? That is that side length. X equals that, 24.8 to one decimal place. So X equals 24.8 meters, that would be in. I need to put centimeters then, because the other length is in meters. All right, so there you go. There's that. I hope that makes sense. Substituting into the rule. Now we'll do the same thing for B. I'm just going to get rid of all that working that I've got there because it just looks messy, and I'm really sorry that it's so small and I have to write so tiny, but I am saying what I'm doing as I'm doing it, so I hope it does make sense and it does all transfer well enough. Let's try and write this one a little bit bigger so we've got a bit more space over here. So let's label this triangle then to start off with, A, B and C. Right, let's go with this being A this time. All right, let's go with this being B and this being C. All right, doesn't actually matter. Now, this is an untidy question for me again because we've got an angle and two sides here, right? And this angle is not included. So if it was included, it would be here, and that would be a different rule. That would be the cosine rule that we'd need to use. All right, but this is a non-included angle. Two sides, non-included angle, sine rule. Okay, so we're going to write out the sine rule, and this time we're going to find an angle. All right, so we've got to change it up a bit. Right, we've got to put the sine bits on top. So sine A over little a equals sine B over little b, which equals sine C over little c. All right, sorry I didn't put the little c's, did I? So little c is going to be opposite the big C, little b is opposite that one, and little a is opposite the big A. Okay, so we've got the a, little a value, and the big A value is the thing that we're going to want to find. So we're going to work out sine of x over 6 is equal to, and then we can't use anything for B because we've got no numbers there and no side length there. So we're using C, we're going sine 42 over 9. Because the angle there of C is 42 and the side length for little c is 9. Okay, now all we've got to do here, two things left to do. Okay, we've got to go sine x equals this sine 42 over 9 multiplied by 6, just multiply both sides of this equation by 6. But this time, because we're finding an angle, we have to inverse to get rid of sine. Okay, so x equals sine to the minus 1. I'm just going to put in here that answer. All right, so I'm going to type that into the calculator. It will be the answer, and I'm going to then get my value of x. Okay, because I was running out of room. So if you can see what I'm doing here, just cover that bit over there. Let's type in sine of, that's not 4, is it? What was the sine? Sine of 42. Right, so sine of 42 over 9. Make sure you close these brackets on the calculator as well. And then we multiply that by 6. Okay, so I'm just going to pop that thing, that calculation there in brackets, just in case my calculator decides to do it incorrectly. 0.44, right? So obviously that's that you'd be thinking, hang on, that can't be the angle, and it isn't, because we've got to inverse the sine to get the angle, remember. Okay, so there's our answer. That's what that bit is. All right, so I'm then going to press shift sine, get sine to the minus 1, then press the answer button, and then close that off and get 26.49, which makes sense as an answer now. Okay, so 26.49 becomes 26.5 degrees. Okay, so there you go. That's how you find a missing side length and a missing angle using the sine rule. Okay, now on to more interesting problems in this world of the sine rule. Shown is a triangle with two possible answers, 4, and this is the symbol for the angle. It's the Greek letter theta. Mentioned it in a different video. Find both solutions. Okay, so it's got two possible answers. Interesting. So what we do is we use the sine rule to find one of the answers, and I'll show you what we do to find the other after that. Now, that angle there is something. All right, that's the one we want to find. Let's call that one A. It's always useful to call the thing we want to find A. And then that's going to be little a. Let's call this one B, and this one little b. And then C is irrelevant. All right, don't need C in this calculation. So we could just write out the A and B bits of the sine rule. So sine of, and then we'll put the theta symbol in, over 7 is equal to sine of 40 over 6. And then we just have to multiply both sides by 7. So sine of theta, exactly the same as the last question B to begin with here. Sine of theta equals sine of 40 over 6 multiplied by that 7. All right, get that calculation, and then we'll get theta equals sine to the minus 1 of that answer. All right, and then that we're going to get an angle there. Okay, so let's type that into the calculator. Get what we need. Remember, it's always about sine because it's the sine rule. And I'm going to type that bit in. Okay, so that sine 40 down 6 close times 7 done. All right, there's our non-inversed answer. So we're going to inverse sine answer equals 48.58. I'm going to write down 48.58 ... degrees. There's one of our answers. Okay, that is a potential angle. Now there is a second angle because it tells us there is, but how do we find it? Well, we've got to think of the sine graph here. Okay, well, this is a way to do this. Now I like to think of the sine graph. Okay, and then we go across here, do a quick little sketch of the sine graph. So between 1 and minus 1, the sine graph goes, it's the wave one. And if you're not sure what this is, go and watch the video on it. Okay, so at 90, 180, 270 and 360. All right, there's our markers that we put down for the angles. So between 90 and 360. We only really need to go up to 180 because it's a triangle, but this is what I always sketch for the sine graph. This is the positive stuff. It does go into the negatives as well. Now, the sine graph starts at 0. Okay, and then it goes at 90 degrees, we get up to 1. And then we go down, back through to 180 degrees, back to 0. And then to minus 1 at 270 degrees. And then back up to 0 at 360 degrees. Okay, so there's a little bit of a horrible mess there. Get rid of that. Just tidy it up a little bit. There we go. So we can kind of just sketch that. And it's easier to do it actually on paper than it is to do on a computer. But that's not a bad job. Now we know that this angle here potentially is 48.5-ish degrees. All right. So roughly where is that? All right. We can just kind of plot it along here somewhere. So it's kind of about halfway. So it's about there. All right. So we know that that is one of our solutions. All right. We also know that there is another solution here. All right. If we carry on, this is solving equations using these trig graphs. All right. There's another solution here. All right. And that is below the 180 degree mark, and therefore it can be one of the angles that's inside this triangle. Okay. So we just have to know what that difference there is. All right. And that's gonna we're going to be able to find that by finding the difference between 90 and this. All right, and that's going to be the same. 90 and 0. What am I talking about? 0 and 48.58 is the difference there. Okay, so we take that difference off of 180 where it's also at 0. Okay, 180 take away this answer is also a potential solution. Okay, so I'm going to go 180 minus that answer is 131.41. Okay, so theta equals 131.41, 6 degrees, 6 ... degrees. Okay, so there's our two potential solutions for that. All right, and it all came from knowing that we could use this graph here, and there's going to be plenty of problems that you could get like that. Okay, so be wary of that one. It will most likely tell you there's two possible answers. That's how you find it. Or there'll be 2 answer spaces or something like that. Okay, right, now third and final question. A hummingbird is hovering above Tony and Ulrika, who are laying 16 meters apart on the ground. The angle of elevation of the hummingbird from Tony is 28 degrees and 24 degrees from Ulrika. Find the height of the hummingbird above the ground. Right, so there's Tony. Let's say that's Tony there. Right, Ulrika is 16 meters apart, so we've got a difference there of 16 meters. Hummingbird is an angle of elevation of 28 degrees, so 28 degrees, say is that, right, and then 24 degrees is that. All right, we're just sketching it. So this hummingbird is like there. Okay, so that we'll call that H for hummingbird. So we've got 2 angles and we've got a side length, right? So it's an untidy question, and it's a sine rule question, obviously because it's in the sine rule video. But you have to kind of figure out these things for yourself when you do these problems. And we're going to find the height of the hummingbird. So we're looking for that distance there. Okay, that height, the perpendicular height. Now, how do we do that? Well, what we've got to do is work out either this side length here or this side length here. And it doesn't matter which one you do, because we've got an angle here and an angle here, and then what we've got is a right angled triangle. I'm going to go with Ulrika's side, okay? Because I loved shooting stars when I was younger, and Ulrika was one of my favourite people in that programme. Well, Vic and Bob, love Vic and Bob, but Ulrika was funny as well. So I'm going to go with Ulrika, and Ulrika is here with 24 degrees looking up at this hummingbird, and we need this height here. Okay, we can get that if we find this this bit here. All right, and how are we going to do that? Well, we're going to use the sine rule. Right, we're going to say that this is t. All right, so we'll call this little t, this side little t. This is u, so we'll call this side little u, and this is h, so we'll call it little h. Right, we'll just change the a, b, and c for t, h, and u. It doesn't matter what letters you use. All right, so we've got t over because we want to find t. So we're going to go t over sine of 28, all right, and that equals, we've got h, we could have h's angle there, actually, because we've got those 2 angles, 24 and 28. So we need that angle there to use in this calculation. That's what I was mentioning earlier as well. So I'm just going to quickly work out what that is. 180 minus that answer is equal to 128. So that's 128 degrees. And then, yeah, we use that in the calculation. So we've got h, which is 16, and then sine of 128 is the number that we pop in to this bit. All right. Now we do the same thing as what we did in the first question. So t equals 16 over sine 128. Let's pop that in the brackets. That's what comes up on the calculator. Multiplied by sine of 28. Okay, now that calculation there is going to get us that side length t. So press that, 16 sine 128, close that, multiply it by sine of 28, 9.53. So t 9.53 ... whatever, right? Now we needed that because we had to have a side length and an angle. Now we had this side length here, but that was the whole base. We didn't know how far along that was, right? So we couldn't just use a number there. We didn't know what the rest of that angle was there either. So we had to have a side and an angle, right? Now we've got the side t and this angle here. We've got this triangle that we can use. So that's 9.53 ... meters, and then that's our angle of 24. There's our right angle triangle. Now we can find the height. Okay, so we'll call that x. All right, and we'll do the calculation using right angled triangle trigonometry. And I'm just going to get rid of the rest of this, so I've got a bit of space to do that in, and we'll get our final answer. Okay, so hopefully you've understood exactly what I've done so far. Just use the sine rule. I needed to work out what that missing angle was in the triangle as well this time, because I couldn't have used any other side length, didn't have any other side lengths. So I had to use the H angle, so I just needed to get that by simple process of working it out from taking away from 180. But here we go. This is opposite, this is adjacent, this is hypotenuse. So you write out your SOHCAHTOA. If you're not sure what I'm doing here, I hope you haven't watched all this video and thought, I can't understand this so far. But this is a different video, so go back and watch this one if you need to. So SOHCAHTOA, we want opposite, we've got hypotenuse, so it's this one, so we get rid of those. And it's the sine rule again, which is handy because we're still in the sine rule video, so it's a sine ratio that we're using. Could have been the others. Yeah, what am I talking about? Right, need to finish this off. So there we go. SOH, formula triangle. Get that written down, and we want O. So we're going to O equals sine of 24, and then we multiply that by the hypotenuse, which is our answer that's still on the calculator screen. So O equals, or X equals, or the height equals sine of 24, close, multiplied by last answer, only once, 3.877. I'm going to round it to that degree of accuracy there. Okay, so that's how high the hummingbird is hovering above Tony and Norika's heads. That's it. All right. But yeah, it takes a while to do, doesn't it? Pretty long video, longest one to date, I think. So I hope you've enjoyed it. I hope it makes sense. Some tricky stuff in there for sure. I mean, this is probably up towards the basic stuff's grade 7. All right, this is more grade 8 and grade 9 potentially even as well. You might get some questions that could be considered grade 9 questions on this topic. So thanks for watching. Stick with me for another one. The next one will be the cosine rule. Take care of yourselves. Bye bye.